Good day, everyone. So today we are going to discuss the different mathematical tools and their uses in the teaching and learning process. Learners frequently and normally use calculators, computers, manipulatives, and other mathematical devices in enhancing their mathematical thinking, understanding, and skill. These tools are used not to replace the mental math and paper and pencil computational skills, but to enhance understanding of mathematics. So out of these four tools, I am going to discuss manipulatives as well as mathematical devices. So let us discuss first what are manipulatives. When you say manipulatives, these are materials that are used for modeling or representing mathematical operations or concepts. The number of models, the number models or multiplication models are concrete models of abstract concepts and operations. Now, when students use bundles of sticks or even single sticks to represent tens and ones, or algebra tiles maybe to represent polynomials, they are using manipulatives here to model mathematical ideas. Technically, even when young children count on their fingers, they are concretely modeling numbers here. So, what are mathematical devices? Mathematical devices are tools or instruments used in the study of mathematics. In geometry, construction of various proofs was done using a compass and a ruler. Now, when we measure the weight of an object, we use weighing scale. We could have the analog or the digital one. Some were still even using the balance weighing scales. Now, if we want to get the perimeter uh, and area of a shape, we need to measure the length of the sides first. So how can we do that? We can use we can do this by using inch and centimeter rulers for smaller objects, and then a meter stick or measuring tape for larger ones. Let us discuss the different manipulatives and mathematical devices in each key stages. Let us discuss first the key stage 1, which comprises of grades 1 to 3 learners. So in key stage 1, manipulatives are the most frequently used learning and teaching tools in mathematics. Usually materials in physical form are used to model mathematical concepts such as number or shape when those concepts are first introduced to the learners. Young learners from grades 1 to 3 counting with beans, colored chips, linking cubes, play money, or their fingers is a familiar sight as they begin to master early counting skills and sooner be acquainted with addition, subtraction, multiplication, and division concepts. Teachers should use additional modern models, though, to start exploring advanced number concepts. So we could have colored rods in graduated lengths, which give young learners a different sense of number. Learners should be able to see both a yellow rod and 5 colored chips as representative of the number 5, the first being more of a measure model and the second as a count model. So another one here, we have popsicle sticks and base 10 blocks. It helps learners begin to understand the very abstract concepts involved with place value. Attribute blocks help learners begin to classify and categorize objects and recognize their specific characteristics. This also allowed them to make patterns and geometric designs as they become familiar with the geometric properties and the shapes themselves. A great variety of different materials should be used to explore measurements. Paper clips, shoes, paper cutouts of handspans, And building blocks can also be used as non-standard units of length. Here in our illustration, students place them down one after another to see how many paper clips long the desk is or how many handspans wide the doorway is. And just bear in mind that we should use handspans and paper clips as the unit of measurement, whichever of the two. So if we are getting the measurement or the length of an object using paper clips and you have 10, then we should write 10 paper clips. So that object is actually 10 paper clips long. The transition can then be made to more standard measures. So as we could see in the illustration, we have the weighing scales. The first one, we have the analog, then the digital, and then the balance weighing scales. Now, as for the here, our fourth illustration, it's a clock model which help teachers teach the learners on how to tell time. And then as for the calendar, it's also a good manipulative because the learners could see the sequence of days as well as the sequence of months. Now, as for the last one, we have the centimeter ruler. Now here, the small lines just give emphasis to learners that the small green lines or the small lines in a centimeter ruler, it indicates 1 millimeter. So meaning there are 10 lines per centimeter. So that the red line, that's per centimeter. And then obviously, as for the blue line, that is a half or that's 0.5 centimeter. As to Key Stage 2, composed of grades 4 to 6 learners, manipulatives have usually not been used as much as they have been in the primary grades. Teachers are devoting relatively little time to learner modeling with manipulatives since they have begun to concentrate on symbolic and abstract approaches to content. It is common for teachers teaching grades 4 to 6 to think that once initial ideas of number and shape have been established with concrete materials in the lower grades, the materials are no longer necessary and a more symbolic approach is preferable. Research shows, however, that materials in physical form and the modeling of mathematical concepts is just as useful at these grade levels as it is for younger learners. The content being modeled is of course different, and so the models are different, but no less important. So learners can use square tiles to model one-digit multiplication arrays in a manner that makes the operation very meaningful for them. And they could also use base 10 blocks to model two-digit multiplication arrays. The extra advantage to this kind of a model is the degree to which learners who have used it can visualize what's happening with the factors in the problem and so can develop much better estimation and mental math skills than learners who have simply learned the standard paper and pencil procedures. The relationship between multi-digit multiplication and division is also clearly shown by such models. Base 10 blocks with the values 1, 0.1, 100ths or 0.01, and 1000ths or 0.001 assigned to the different sizes here. It model operations with decimals just as well as the values normally associated with base 10 block model with whole number computations. Now, another one for geometry models, both 2 and 3-dimensional, are a vital part of learning about geometry and advancement of spatial sense in learners of this age. We could also have GEO boards, so learners could explore area and perimeter and to begin to develop procedures for finding the areas of irregular shapes. Now, the next one, we have play money. So, it's a measurement for value to concretely construct solutions to coin problems or to riddles that ask how much an individual actually profited or lost in some complex business dealing. And as for other mathematical devices, we could still use the weighing scales. And then here we do have the triangles. It helps us um, draw parallel lines, perpendicular lines, or even it could also help us draw angles. So here we also have the protractor and the circular protractor as well as the compass. If we are going to discuss on how to measure degree measure, we are on how to get the degree measures as well as on how to construct circles. Now just bear in mind that teachers should bring a bigger version, a larger version of these tools so that they could demonstrate on how to properly use these tools. For Key Stage 3, that is composed of grades 7 to 10 learners. They can use different manipulatives to enhance their mathematical understanding and problem-solving ability. New approaches to the teaching of elementary concepts of algebra include concrete materials at many levels. They could use two-colored counters, and these may represent positive and negative integers as learners build a sense of operations with integers. Mind you, teachers, this is a very good strategic intervention in teaching the operations of integers. Now, another one, the algebra tiles. These are used to represent variables and polynomials in operations involving literal expressions. It is probably the best investment for beginners who want to build a solid foundation of algebra concepts. Algebra is a topic that you can hardly skip any part of. If you do, there is a possibility that understanding it completely is just out of your reach. So as you jump to the higher levels. Now, we could also use clay models for geometry. So, slicing clay models of various three-dimensional figures, it convinces learners of the resulting planar shape that is the cross-section. They might build models of a pyramid with a square base and a cube with the same size base to use in an investigation of the relationship of their volumes. Learners can also use Mira to do reflective geometry to find the center of a circle or a perpendicular bisector of a line segment. Here, for statistics topic, they might use coins, dice, or play cards to simulate a variety of real-life events in a probability experiment. Now, as for other mathematical devices, we still have the triangular ruler, we have the protractor, compass, and then also a scale ruler. And then we could also introduce the use of a slide rule. And lastly, we have the key stage for senior high school learners or the grades 11 to 12 learners. Now in our school, we don't offer mathematics subject for grade 12 level, but I am not really quite sure with other schools in Davao region. Anyways, As we all know, many learners move on to study advanced concepts in mathematics with a shaky foundation. So learners from senior high school can also use a variety of manipulatives to enhance their mathematical understanding. We could have the XY coordinate pegboards. This can be used to graph coordinates in 1, 2, or 4 quadrants. It shows translations of geometric figures, display data in various forms, and demonstrate numerous algebraic concepts and relationships. Now, another device or manipulatives, we could have the centimeter grid dry erase boards. So it could be used to teach data collection and statistics in an interactive way. This gives learners an opportunity to try out individually, thus encourages participation, which is so much required in learning mathematics. This could also be used as This could also be used in drawing graphical representations of various algebraic functions. Now, coins, dice, marbles, or play cards, we could use that to simulate a variety of real-life events in a probability experiment. Now, as for other mathematical devices, there's no much of a difference from the junior high school or the key stage 3. We also use triangle, scale ruler, slide rule if you do have one, protractors, and compass. Now, I am going to share a video on how to use a slide rule.
When you're doing things with decimals or pi, they do not provide an totally accurate answer. They provide an estimate that is good enough to complete your job, but not perfect. For example, you can see pi labeled there. My camera ever focuses there, and this will be a two-part series with the slide rule. And today I'll be showing you how to multiply. In part 2, I'll be showing you how to divide. So, if you look closely, the slide rule has lots of scales on it. A, B, C, the other C, D, and K. So, but today we're only going to be using A and B, and for division we'll only be using those two. So let's start with something simple and multiply 2 times 4. So we're going to find 2 on A. We're going to slide 1 on B right under where 2 is. And then we're going to use our hairpin to find where 4 is on B. And it is there. And right above 4 you can see that that is 8. So that tells us that 4 times 2 is 8, as we already know, hopefully. Now let's try another example. Slide everything back to its beginning position. Let's try 5 times 7. Now this is where it gets interesting. If I move the 1 under the 5 and try to find the 7, but what is this? The scale has repeated. It has gone up to 9 and it goes back to 1 through 9 again. This is, even though there's no 0 after any of these numbers, this is usually representing 10, 20, 30, 40, etc. However, if you're using larger numbers, such as the thousands, these could also represent 1,000 or 1,000,000 or 10,000 or any number like that. You just need to know where to place your decimal so that your measurements are accurate. Or not measurements, but your values are accurate. So we're multiplying 5 times 7. So there's the 5. Now we go over here on B scale. We find 7. And that halfway between 30 and 40 is 35. As we know, 5 times 7, is 35. And that's all you need to know for multiplying on a slide rule like this.
So that's it. We have another video here on how to use a scale ruler.
Hey guys, so today's actually pretty cool because I am going to be explaining the way a scale ruler works because I started using it this semester and at the start I was just so confused, like what the hell is this? Doesn't make any sense, but apparently it does. So here we go. Basically we had this assignment to draw this bed and this dining table in 3 different scales, which was 1 to 100 and 1 to 50 and 1 to 25. Now, first thing I'd like to show you is the way I did that. So we'll notice something pretty cool here. The fact that the 1 to 25 is the biggest, and then as the number gets bigger, so 1 to 50, the size gets smaller, so that's half of that, and 1 to 100, that's half of that, even though 1 to 100 is the biggest number, but we find that it's the smallest one. Now, let's just get... Oh, and also I'm dealing with a metric system, not like feet and inches. Like, no, I don't use that, right? I use meters and centimeters. So, let's start with the 1 to 25, and on my ruler, it's 1 to 250. That's the same thing because this one is actually in millimeters. So, and then I'm doing centimeters, so that's just the 10 difference. But the 1 is actually, it means 1 meter. So on my paper here, it says that this length is, the length of the bed is 1.7. Okay, so 1.7 meters, that's what they mean. So to turn the 1.7 meters into our scale, which is 1 to 25, we go to the 1 to 250, which is the same thing as 125, and we go to 5 meters, 6, 7, that is 7 meters right there. And so when I draw it, awkward. Oh, sorry. Yeah, so there's 1, because I said we're dealing with 10s because it's 150, so the 10 is actually a 1 and then the 20 is actually a 2. It's gonna go to 10, 15, 16, 17, and that's actually 7. Yeah, so see that? That's actually 1.7, sorry. Alright, so let's take a look at the 1 to 50. So we go to the 1/500, that's what we're dealing with, and again this was 1.7. It's also going to be 1.7 except on a different scale. So there's the one right there, which is the 10 centimeters, and 10, just like on a normal ruler, what you do is 15 on that middle one, and then 16, and then 17. There you go. Same thing here. You go to 1 to 100. Where's that? Oh, it's right here. And the 1 to 100 is actually the same one as a normal ruler, where you've got like 10 millimeters and 1 centimeter and stuff. So there's 1.7 right there. Anyways, I hope you found this video a bit helpful.
And that's it. We have another video on the next slide.
In a minute. So obviously you can draw vertical lines with a triangle, right? I think I started it. I have a video on that one. And this, of course, you can draw a 30-degree line. This is 30 degrees. As well as this is 60 degrees line. And moving on to the 45. You have this 45 degrees line. So this is 45. You can also use the combination of these two as well. So for example, this line, 30 plus 45, you get 75. This is 15. So you kind of cover this range here. And this is 0, obviously. And of course you can draw parallel lines, right, with the triangle, as well as you do. And when you do that, this becomes perpendicular. That's really it. Okay, let's talk about this adjustable triangle. So let's say you have a very specific angle that you need to dial in, and that angle cannot be produced by these two triangles, the 30, 60, and 45, right? We just talked about this. Let's say that angle, let's make believe it's 22 degrees. And you can, there's a little magnifying glass. I'm trying to get it close to the camera. I'm sure you guys can see it. Right, that is 20, so it's 20. That's 30, so that's 22 degrees right there. So this angle is at 22 degrees. So what is perpendicular to 22 degrees? This exact over here, that is 68, between 60 and 70, so that is 68 degrees. So this is 68 degrees because this is 90, right? 22 and 68 goes 90. So that's how you would do. So that's how you use this adjustable triangle. So that's it.
And that's all for manipulatives and mathematical devices. Thank you, and I hope you have learned something.